All right, number 8, we want to match the function with its graph, and we are given f of x is x plus 2, and this works when x is less than 1. Okay, so less than tells me open circle. Okay, so I can either choose between what I would say this is B or C, the two in the middle. I would not use this one because it has two closures on the front and the back end, and this one only has one closure on one side. I want to go ahead and show you how to graph a piecewise function with a calculator. I think it's really neat. It's not something that is required, but it is something neat to learn how to do. So I want to show you how to do that. But it's basically the same as graphing a regular linear equation, but just having a cutoff point so you don't graph the whole thing. And I am losing where I just placed my marker. But let me just go ahead and show it to you in the calculator. So I'm going to go to y equal. I'm going to turn this on. I'm going to go to y equal. Now, when you want to graph a piecewise function, we want to put our equation in parentheses. So I'm going to open parentheses, and then I'm going to type the x plus 2. And then close parentheses. All right, so once we have the x plus 2, we are now going to do divided by. Divided by is what's going to allow us to impose the restriction. So type divided by, and then we are going to add the restriction. So you're going to open parentheses again, and then we're going to do x, and then we're going to do less than. So how do we get less than? Well, above the word math on this calculator in blue is test. So if we do second and then math, it brings up those inequality symbols. Number 5 has the less than, so I'm going to hit 5. So we have x less than, and then I'm going to put the number 1 and close parentheses. Now if I hit graph, it shows me a line that just kind of comes and it kind of stops, and you can, if you look at the tick mark, that's at 1. Now if I trace this graph and I put in x equals 1, okay, doesn't give me a y value. So it says x is 1, y is nothing, because it only works for less than 1. Now if I started going to the left, as soon as x is a little bit smaller than 1, I start getting y values, okay, all the way over. But if I arrow to the right, as this little cursor is tracing along that line, once it gets past 1, there are no more y values. So I can just keep going to the right, but there's nothing there. Okay, so it continues to graph it as though the graph was up there, but there's no y values associated. So anyway, the middle graph looks to match this piecewise function. All right, we're going to do the same thing for number 9. We want to graph, so we got 2 pieces. I'm going to go back to y equal. I'm going to clear this out, and I'm going to open parentheses, and we're going to do the absolute value of x. So how do we get absolute value? We got to go to math. We're going to go back, or sorry, go right to number, and then this ABS. This is the calculator's abbreviation for absolute value. Hit enter, it brings you absolute value to the y equal screen. Type in x, close parentheses. To impose the restriction, I have to do divided by, and then I'm going to open parentheses and do x is less than, so we got to do second and math to get those less than symbols, number 5, and then 3. And then the second part, open parentheses, we have negative x plus 6, close parentheses, divided by for the restriction. And then I'm going to open parentheses and do second math greater than or equal to, so option number 4. Sorry, I need the x in there. Second insert, get the x greater than or equal to 3. Now, say you don't have calculator, you can't graph this. How could we do this by hand and see what this looks like? Okay, so hopefully you know the absolute value function is just a V shape, up 1, right 1, not spaced to scale, but absolute value does a V shape. Okay, this graph is working for x is less than 3. So if I go up 1, right 1, that's 1, up 1, right 1, 2, up 1, right 1, 3. Less than 3, open circle. So this graph would look like that. So the absolute value of x less than 3 would be V-shaped, but it would cut off at 3. Now the next graph is a linear expression. So negative x plus 6. This graph would be just a linear function with a negative slope, but it picks up at x is greater than or equal to 3. So if I was to graph this normal, I would be at 1, 2, 3, 4, 5, 6. So here's where we would be. We would go down 1, right 1, no point. Down 1, right 1, no point. So this is x equals 2. Down 1, right 1. So it picks up pretty much right here where that open circle was. And then it continues to go down 1, right 1. So it's like the graph just kind of flips that part and goes like this. So this is what we're going to see in the calculator once we hit graph. And so you can kind of see that shape right there. So if you know how to graph the basic and the parent functions, which we have those there for you, you can graph any piecewise. So this one wants us to graph it. I'm going to do a line segment at the origin, up 1, right 1. So that's going to be the left side of this graph. We're going to do a ray starting here, and up 1, right 1, up 1, right 1, up 1, right 1. So that's going to be the last point of that ray. I'm going to do a hollow dot right here. Okay. Then I'm going to graph the negative x plus 6 when x is greater than 3. So I'm going to put a solid dot, same spot, and we're going to do a line segment starting here, and we're going to go down 1, right 1. And so that's going to be our graph.